Hey there, Mrs. Banky here. Today I'm going to start a series on what's called nomenclature of chemical compounds. And nomenclature sounds like a scary word, but it's really not. What it involves is naming compounds and writing formulas correctly. There are a lot of compounds that we learn about in chemistry, and they fall into different categories. One of the difficult things about naming compounds or the nomenclature of chemical compounds is that it has to be determined what class the compound is in. And we're going to talk about the different types of chemical compounds, and then specifically later in this episode I will talk about binary ionic compounds. I do want to say that I am trying out some new equipment today, so if you hear any brief moments where there's no sound, I don't really know how to explain that, but I'm just using my iPhone, my earbuds as a microphone, and it seems to be working with the exception of the omission of sound very briefly every now and then, so please try not to let that distract you too much. So with that said, and another thing, there's a volleyball game going on, so there might be some background noise coming in there, and I hope it doesn't cause too much of a distraction. So with that being said, let's talk about the different types of compounds in chemistry. The first three types we will learn about pretty extensively over the course of this year. A lot about ionic compounds and binary molecular compounds to begin with, a little bit later discussing acids. Okay. Hello. Okay. All right. Okay. Bye. I almost fell off the chair. That was my mom calling. I might just leave it in here to show you that I'm having a difficult time putting this together because I keep getting interrupted. So maybe I'll just leave the interruptions in there. And I put my earphones in the wrong way. It's important to put the right in the right ear. There's a little R on there, and the left in the left ear. Okay. So once again, we're going to be learning about extensively ionic and molecular compounds to begin with, a little bit later acids. And if you take advanced chemistry with me, we will look at how to name and write formulas for organic compounds very extensively, and that's a lot of fun. I forgot what I was going to say just there. Oh, now there's a trumpet playing in the background, and I'm not sure if you'll be able to hear that, but I guess we'll find out. Sounds pretty good. I forgot. Looking at the different types of compounds in chemistry, we can see that there are 4 different types that I have listed here. And one thing that makes nomenclature of compounds a little more complicated is that each compound type has its very own naming system and mechanisms for writing chemical formulas. In this class, we will study ionic compounds, binary molecular compounds, and acids pretty extensively. If you take organic chemistry with me, or advanced chemistry with me, it's a semester-long class. We study organic compounds quite extensively. I call it organic chemistry a lot because that's one of the main focuses that I have in the class, and it's really a lot of fun. General thoughts on why it's important to name compounds and write formulas and and just learn the language of chemistry. In a lot of ways, it's like learning a new foreign language, and it shouldn't scare you. Most students think it's pretty fun, especially if you're good at pattern recognition. Like I mentioned before, each compound type does have different rules for naming and writing formulas, so it's kind of like learning dialects within a foreign language. I will help you with the skills that you'll become really good at, and like I said before, it will provide a really good foundation to help you over the course of the year. So, binary compounds contain two elements, and the first element is always a metal cation. Remember, metals often have 1 or 2 or 3 valence electrons, sometimes 4, sometimes 5 and 6, but commonly 1 to 3, and they lose those valence electrons to leave behind positively charged ions. And that gets electrostatically attracted to a nonmetal anion, which is typically a metal or a nonmetal that has 6 or 7 or 5 or 6 or 7 valence electrons, and it often will gain 3 or 2 or 1 valence electrons to fulfill the octet rule. A reminder of the octet rule that an atom will react to achieve a noble gas electron configuration. One way this can happen is through ion formation. We will talk extensively about ionic bonding and the mechanisms involved with that later, but it's not really that essential to concentrate on that to learn how to name ionic compounds. These are some of my favorite examples of binary ionic compounds. One is iron 2 sulfide. This is also known as iron pyrite, which is also known as fool's gold. And iron 2 sulfide has very beautiful gold crystals, and we can actually make this in the lab if you combine sulfur powder with iron powder and heat it up pretty intensely. We can form these really pretty crystals, and we'll explore that sometimes later this year. So another type that is one of my favorites, and it's an example that we use all the time in chemistry, is sodium chloride. These are some beautiful sodium chloride crystals, and this is how it forms in nature. Not always in large, beautiful crystals like this, but it's weird to think that the sodium chloride that we eat on our food, which is just table salt, actually forms in nature like this, and we mine it. There are sodium chloride salt deposits that we mine, and that's a source of the salt that we use on our foods. This is another one of my favorite binary ionic compounds. If any of you have ever seen a magnesium strip of metal that has been ignited, it gives a brilliant, very intense glow, and we will typically tell you don't look at the glow because it could cause eye damage, which is similar to welder's flash. But the shiny magnesium metal, which you can kind of get a glimpse of right up in here, will ignite and form a crumbly powder. Now, the crumbly powder is not necessarily my favorite because it's really that interesting to look at or beautiful, but the reaction itself to get the magnesium oxide powder is very spectacular. So when we name ionic compounds, the metal cation is always written first, and the nonmetal cation is always written second. Some things to remember when we're naming ions is that a nonmetal ion name always ends in IDE. So since it's written second, ionic compounds, binary ionic compounds, will always end in IDE on that second word. Also, if that metal can have more than one charge, like iron and lead and copper and nickel and chromium, and those are just to name a few. We have to indicate what charge is on the ion that makes up that compound, and to do that we use the stock system, which is the Roman numerals in parentheses, where the Roman numeral is equal to the charge. So for example, an iron ion with a +3 charge is called iron 3 ion. And the stock system uses that I'm trying to use my little drawer here. It's not the greatest, but uses the Roman numeral that is actually equal to the value of the charge. If it was iron with a +2 charge, we would call it iron 2 ion. The classical system uses the classic name of the element. Iron used to be called ferrum, and I'll spell that right up here, ferrum, F-E-R-R-U-M. Sorry about the messiness here. And with that, if the charge is the higher charge, we would call it ferric ion. So this would be called ferric ion. And if it were iron with a +2 charge, it would be called ferrous ion. So with a +3 charge, ferric, and with a +2 charge, ferrous. Here's an example of another example of an ionic compound that can form from calcium oxygen is called calcium oxide. So again, the name of the metal ion first, the name of the nonmetal ion second, and ending in IDE. This is known as quicklime, and it is used in the cement industry to act as a binder in making cements. They used to put it on baseball fields and football fields, but it's actually quite a caustic substance. So they stopped doing that. It was quite dangerous to the players. If you ever are making cement and you get some of this on your hands, it can cause severe burning and itchiness and a dry flaking of the skin that can be very painful. I've experienced it myself. It was not that great. When we're writing formulas using the crossover rule, or to write formulas for ionic compounds, we use something called the crossover rule. So to determine the formula of the binary ionic compound, the first thing that we do is we write the formulas of each of the ions. Then we take the value, the absolute value of the charge on the cation, and that number is going to become a subscript down in front of the anion. And we take the absolute value of the charge on the anion, and that's going to become a subscript, which is written down low, in front of the cation. So since lead can have more than one charge, this the name of this substance would be lead 2 nitride. Lead 2 is the smaller charge of lead. Another option is lead 4. So since this is a smaller charge, using the classic system, we call this plumbous nitride. One thing I forgot to mention earlier is that if the subscripts can be simplified, they should be. And there's an example of that on the next slide. As I was just talking about, there are times when we use the crossover rule in which we need to simplify. So if you look here, lead with a +4, which is lead 4, and oxide with a -2 charge, if we use the crossover rule, the 2 comes down in front of the lead as a subscript and the 4 comes here. Since they're both divisible by each other, in ionic compounds we have to simplify to the simplest form. So lead 4 oxide becomes PbO2. Here's an example where you have opposite and equal charges. Lead with a +2 charge is called lead 2, or it's also called plumbus, as opposed to lead 4, which can be called plumbic using the classical naming system. So here we have lead 2 sulfide or plumbus sulfide have opposite and equal charges. When the crossover rule gets used, you can see that this can be simplified to PBS. Now the really exciting thing about this substance is this is our state mineral, and it's known as galena. This is the reason that we're known as the Badger State. We were a very active mining state, especially down in southwestern Wisconsin, where there was a very large Norwegian population. And the Norwegian people would often build their homes into the sides of hillsides, and people thought that that resembled the way that badgers lived, so they referred to as the Badgers. And since we have a strong mining heritage in Wisconsin, we have since become known as the Badger State, and this very beautiful galena is our state mineral. So this nearly concludes my series on binary ionic compounds and how to name them and how to write formulas. Again, in conclusion, the amount of time that we recently spent on naming ions and writing the formulas of ions is now coming in handy with being able to apply that knowledge to naming compounds and writing their formulas correctly. Clearly, if you don't have the right charge listed on an ion, you're not going to end up with the right formula. So it's important that we begin to master this at this stage, because this will keep getting used again and again and again over the course of the year. I'm going to just try to do some examples on the next slide of more binary ionic compounds, and that'll be the conclusion of this part. So if I activate the pen here, so I'm just going to write down some formulas, and with that we can practice naming. So I will do Na2O and MgS Al2N3 and Fe2O3. This is kind of sloppy. It looks like a kindergartner's writing, but we'll go with it anyway. So again, to name the binary ionic compounds, we use the name of the cation followed by the name of the anion. Since anions are always negative, and negative names always end in IDE, every single one of these is going to end in IDE. So this becomes sodium oxide. This becomes magnesium sulfide. I have a bunch of loud, chatty girls out in the hallway right now. I'm not sure if you can hear them or not. This becomes aluminum nitride. And here we have an iron compound. Now, iron can be found in more than one charge. So knowing that oxygen has a -2 charge and kind of working backwards for the crossover rule, in this case, the iron must have had a +3 charge. So this is iron 3 oxide. I'm just going to clear this so that I have more space to write. I'm not sure if I can clear it or not. Well, maybe I'll just try to write near the bottom. So I'm just going to write some names now and then demonstrate how to come up with the formula. So let's say we have silver oxide. You can see oxide is one that I commonly choose. When we do this, in order to get the right formula, what I like to do is, if we're given the name, oftentimes I'll suggest you scribble the ion formulas up above the name. So here, silver, when I look in the periodic table, I see that silver has a plus charge, and oxide, oxygen, has a -2 charge. When I use the crossover rule, that's +1, we don't write ones, but the 1 would come here, the 2 subscript would go there. So when we write it together as a compound, we get Ag2O. Here I'll try another one. Let's take zinc chloride. My pen was not running this choppy before. So again, writing the ion formula of each above. Zinc has a +2 charge, and chloride, chlorine ion, has a -1 charge. So crossover rule, ZnCl2. So this concludes my discussion on binary ionic compounds. On to the next part is part 2, where I'm going to talk about ternary ionic compounds. Those make some really neat substances too that I would like to include examples of, and share some of the fun chemistry that exists when we're talking about some of these compounds. One thing that I encourage you to do at this point is start looking at your labels. Read the backs of food labels and beauty products and shampoos, conditioners, and start looking at some of those ingredients, because you might be surprised how many things you start to recognize as you look at them. So thanks for watching. I'll see you in the next part. So if you still happen to be watching, you may have gotten the impression that I've gotten interrupted a few times. For example, right now the pep band is playing. I'm not sure if you can hear them, but they're playing "Hey Baby, Would You Be My Gal, Girl," something like that. And I have some students knocking on the door. But if you care to keep watching a little bit, I have an incident where I get interrupted by my kid and he becomes part of the video, and it's just kind of fun. Don't feel obligated, but that's going to be it. Two types of ionic compounds that we're going to look at are binary ionic and ternary ionic. Binary ionic simply contain...
I got things.
That's good.
What are you listening to?
I'm not. I'm making a video recording.
No,
You kind of screwed me up.
sorry. Is that going to be in the bloopers?
Mm-hmm.
Am I in it?
You are now. We got to start over.